Can you see my screen?
Yes, sir. Yes, sir.
Okay.
Today's topic, temperature. We advise you to watch State of Matter and Change in Matter videos first. Then you can understand temperature video better. Why are you taking so much time in drinking soup? Oh, this soup is very hot. Oh, I feel having fever today. My body is very warm. You know, in fever, your body temperature goes above normal. Yeah, but body never gets as hot as soup. My soup is more hot. How do you measure that? What is more hotter than the other? Oh, I know this. Let me show you something. Okay, see these three jugs? Yes, there's water in these. Tell me, which one is hotter? Yes, jug C is more hotter because smoke is coming out. Oh, it is too cold. Yeah, it is very cold. But can we touch everything by our hand to check the heat? No, it is dangerous. We may hurt our hand. Yes, you're right. Do you know why things are hot or cold? Oh, it depends on amount of heat in a thing. You're right. It is called temperature. The amount of heat in a thing is called temperature of that thing.
Yeah, here amount of heat in a thing is also called as temperature. Okay, temperature. So it is simple. You can see in the three mugs, in mug C, there is a smoke is coming out. So that means heat energy in mug C is more. So that is why temperature is more. So in this video, they are giving you the introduction to temperature.
Okay, with magic word, let's see what a molecule is doing in this jug. Can you see the molecules in these jugs? Yes, in jug A, molecules are contracting due to cold. Things contract in cold because molecules tend to come close to each other. Tell me, what do you see in jug C? In this jug, molecules are moving fast.
See, jug C is a very high temperature, so that is why the molecules are moving very high. Okay, they are moving like fast vibrations, we can say. The molecules are vibrating very fast.
They are going away from each other. Yes, things expand when the molecules move away from each other. Things expand when they get heat as molecules run away from each other. We will see this with an experiment. Here are two balloons. I am keeping one in refrigerator and one in sunlight. Do you know what would happen? I know. Balloon in sunlight would become bigger. And balloon in refrigerator would contract. Means it becomes small. Oh, this means things could. No, balloon in sunlight would become bigger. And balloon in.
See, and you are taking up two balloons, balloon in sunlight, one balloon you are keeping in sunlight, and another balloon you are keeping in refrigerator. So you are taking initially same volume, then you are keeping it, one is at sunlight, one is at refrigerator. Then what is happening in the refrigerator? The temperature is less, so for that is the reason balloon contracts. and in the presence of sunlight the temperature is more. So for that is the reason gas molecules expands and balloon also expand. Gas molecules inside the balloon expands, so balloon also expands.
Refrigerator would contract, means it becomes small. Oh, this means things contract in cold and they expand in heat. Yes, that is why they keep a gap in railway tracks. So that in summers, when iron of the track expands, there's enough space for expansion.
So do you know in between two rails, have you observed in between two rails there is a gap? Have you observed or not?
Yes, sir.
Yeah. So do you know what is the reason behind it?
Yes, sir.
Yeah,
Sir,
what
I
is the
know.
reason, Shivangi?
Sir, because when the trains are moving, then more heat is produced by the wheels of the trains, so that it expands.
Yeah, very good. During the summer, the railway tracks that it is made up of steel. Steel expands on heating. So to avoid accidents, okay, to to avoid if there is no gap, then what will happen? If there is no gap, what happens? If there is no gap, then you will observe that the rails may come one above the other. The rails may come one above the other. The steel parts may come one above the other. Then it may lead to train accidents. It may lead to train accidents.
Things contract in cold and they expand in heat. They keep gaps in railway tracks because of this. I want to show one instrument of measuring temperature. What is inside this tube? It is mercury, a liquid which expands and contracts very fast. Oh, that is why Mama uses it to measure body temperature. Yes, if your body is cool, it would contract, and if it is hot, mercury would expand. Yes, in this way, we can measure temperature. I am so tired. Seems because of fever, my temperature has gone up. I am going to sleep. You also sleep.
So that is the principle behind the thermometer. Okay. So on when you bring thermometer near to the hot body, then mercury expands. Mercury expands. See, the thermal expansion only resulting in a temperature reading. Okay. So in behind the mercury thermometer, the principle is thermal expansion. Thermal expansion. Okay. So this thermal expansion, how it takes place in solids, liquids and gases, that we will be learning step by step. In liquids how it will be, in solids how it will be, in gases how it will be. We will be learning this. Okay.
Get well soon. I want to play with you. In your dreams, my magic wand would show you many things about temperature. Let's see what is happening in Jimmy's dream. In summer, these railway tracks expand. That is why they keep gap in railway tracks. On heating, air molecules in balloon expand and it becomes lighter, so it goes up. On heating molecules expand and air become lighter.
So this, have you ever
On heating, air molecules in balloon expand and it
have you ever used this hydrogen balloon like Diwali cracker as a Diwali cracker? Have you ever like lighted the hydrogen balloon? Have you ever used?
Yes.
Yeah, this hydrogen balloon, na, what you are doing actually, you are when you are lighting a candle near to it, then the gas, there is some chemical reaction, the hydrogen gas is evolved, and hydrogen gas gets heated, then it expands more and more, and it it rises up. It rises up. So that is what happening.
becomes lighter, so it goes up. On heating, molecules expand and air becomes lighter. It is 20 degrees. It is called room temperature. It is 50 degrees. It is hot. Temperature of normal human body is 37 degrees. Room temperature.
Room temperature is around 20 degrees Celsius or 27 also we can say, it varies. It is in between 20 to 27 degrees Celsius, and temperature of the human body is 37 degrees Celsius.
Temperature of humans 37 degrees Celsius. Oh, it is too hot. This fan would bring the temperature down.
Okay, so we are just giving a little introduction about thermal expansion only. So this video tells about like thermometer, our next video. Acha, in the previous video, any doubts? Any doubts in the previous video?
Sir.
Huh?
No, sir.
Okay, good. Very good.
Sir.
Yeah.
Sir,
Shivangi?
but that boy was measuring the liquid and the other object with clinical thermometer.
No? No, no, no. We cannot measure it with a clinical thermometer. How can you say it is a clinical thermometer?
Sir, there was king I saw.
No, no, no. It should not be a clinical thermometer. It should be only laboratory thermometer.
Okay, sir.
I want to show one instrument of measuring temperature. What is inside this tube? It is mercury, a liquid which expands and contracts very fast. Oh, that is why Mama uses it to measure body temperature. Yes, if your body is cool, it would contract, and if it is hot, mercury would expand. Yes, in this way, we can measure temperature. I am so tired. Seems because of fever, my temperature has gone up. I am going to sleep. You also sleep. Get well soon. I want to play with you. In your dreams, my magic wand would show you many things about temperature. Let's see what is happening in Jimmy's dream. In summer, these railway tracks expand. That is why they keep gap in railway tracks. On heating, air molecules in balloon expand and it becomes lighter, so it goes up. Once heating molecules expand and air become lighter. It is 20 degrees. It is called room temperature. It is 50 degrees. It is hot. Temperature of normal human body is 37 degrees. Room temperature. Temperature of human. 37 degrees Celsius. Oh, it is too hot. This fan would bring the temperature down.
So next video tells about matter states.
Here is from www.
There are different states of matter. So what are those states? Do you know?
Sir, solid, liquid, and gas.
Yeah. Okay. Very good. So let us start learning, and then we'll learn thermal expansion of solid, liquid, and gas.
MakeIngredients.com. If you want to see more science videos, go to www.makeingenious.com. Yeah, and it's free. State of matter. Is it tasty? Yeah, very much. But I won't give you. Okay, my magic wand would give me. Oh, mine is better. There is no smoke in yours. Smoke? See, the smoke is coming out. Oh, this is gas. Gas? What is gas? Okay, let me tell you something. All things in the world exist in three forms. These are solid, liquid, and gas, or air. See, this is liquid. And see this cup? This is solid. And the smoke is coming out of your cup. It's gas. I don't understand. Solid, liquid, gas. My magic wand would show this. See, here are three forms of water. Can you tell? Yes, this is solid. Oh, this is liquid. And this is gas. Do you want to see the difference among solid, liquid, and gas? Yes, yes. But how? Let's become very small and see these things from inside. Let's first enter the solid. Oh, what are these small things? These are small lumps. Everything in the world is made of small molecules. Oh, in Greek, small is moles, lumps is cold, so small lumps is called molecules. In Greek language, small is moles, lumps in cold, so small lump is called molecule.
So in every body, solid, liquid, or gas, they are consist of molecules, and in the molecules there are atoms. Within the atoms there are electrons and nucleus. Within the nucleus, protons and neutrons. So this is what it is about matter.
Oh, it is very tight here. I can't even move my hands. Molecules in solid are very close to each other, and so they have less space to move. That is why they move very slowly. Now I know they are very tightly packed. That is why they have a definite shape. Now let us move into liquid. Aha! Here's a lot of space. Yes, molecules in liquid are away from each other. That is why they are able to move fast. Oh, they are not tightly packed, so they can go in any container and would take that container's shape. Hmm. Liquid molecules are apart and they take container shape. Let's see how liquid changes shape. See, I was right. You put liquid in any container and it would take that shape, right? Yes.
Yes, no, solids have definite shape, but liquids and gases do not have their definite shape. Whatever you take the container, in that container, the liquids and gases will take that shape. Okay?
You're right, genius boy. Let's enter the gas now. Aha! Here molecules are apart from each other. And see how fast they are moving. That is why they don't have a shape. Yes, molecules are far apart and gases don't have a shape. Let's again see all forms of matter. So, this is solid. Yes, that is why it has a definite shape. In your hand, water is in liquid form. Yes, and it takes the shape of the container. Like if I pour it in the glass, it would take the shape of the glass. Let's see again how molecules move in solids, liquids, and gases. Oh, now I can tell. This is solid like spoon, and it is liquid like juice, and this is gas like in a balloon. Yes, you're right. Let me note down all these things. Now you're going to www.makemegenius.com for science videos. It also has lots of interesting facts in PowerPoint.
Yeah, any doubts? Any doubts here?
No, sir.
Anyone else? Any doubts? Krishan Agarwal, any doubts? Soumyajit?
No, sir.
Yeah. Next. Next. How this changes, how the changes in the states takes place. Okay, let us try to understand. We have understood? We have understood three states of matter: solid, liquid, and gas. And is there any change in state? How we can change the state from solid to liquid, or liquid to solid, solid to gas, or gas to liquid? So let us try to understand that.
Topic: change in matter. Oh, I can't finish it fast as it is melting. Oh yes, mine is melting too. Why is this melting? Let me show you something.
Why it is melting? Why as soon as you take the ice cream, why it is melting in your hands? Can anyone please?
Sir,
Yeah.
sir, because solid is changing to liquid form.
Why?
Sir, because of heating it.
You want
Because
to
the
heat
body
it?
heat is transferred to the ice cream.
What is heat? Only body's heat is transferred?
No, sir, the environment heat too.
Yes, yes. Very good. Very good.
Why have you brought me back? Let's find out the secret why solid like ice cream melts. Oh, secret? But then these are ice cubes. Yes, it is called the secret of molecules. You know, everything is made of molecules. When you heat molecules, they start moving faster. Then what happens? Let's enter the world of molecules to see this. You know, these molecules in solid are tightly packed and they don't go out, but they're not fixed. They keep moving. They come near to each other and then again go away, like saying, I'm your friend. And no, I'm not your friend, like you and me. Yes, but when it gets hot, they start moving away.
So what is happening actually at room temperature also? Okay, at room temperature also, even if you do not heat any body also, at room temperature, the molecules are gets vibrating always, always. Okay. If you take your mobile phone, if you take your table, or if you take your laptop, okay, whatever you take, whatever the matter you take, the molecules in it, they are always vibrating. They are always vibrating. Okay. Why? Because room temperature is there. Because of that, they always vibrate. And when you are heating it, these vibrations become faster and faster. When you are heating it, these vibrations become more faster, more number of vibrations, and that leads to expansion. That leads to expansion. And if you further and further increase the temperature of the body, then it turns from solid to liquid.
From each other. And you know, when molecules are far from each other, what happens? Yes, matter becomes liquid. Yes, it is also called melting. Melting. When molecules in solid become apart, it turns into liquid. Now, still we are heating the liquid, so molecules are moving faster. Some of them are coming out. We can see them, but they're forming a gas. So, when vapor comes out of liquid on heating, it is called evaporation. Vapors! Vapors! Evaporation!
Okay. So in this way, so for example, if you are increasing the temperature of the solid and you are increasing the temperature up to melting point of the solid, then it gets melted. Okay, it turns into solid to liquid. Then if you are further increasing the temperature of the liquid, okay, it evaporates at boiling point. Okay, so for example, ice cubes you take from 0 degree Celsius, you increase even 1 degree Celsius also, it changes its state from solid ice to liquid water. And the same liquid water, if you are changing or if you are increasing the temperature further, then the liquid water converts it into water vapor into gas form, gas form. Okay, so so in this way you can increase the or you can change the state of the body from solid to liquid, liquid to gas. And if you decrease the temperature of the gas, it becomes liquid. and if you decrease the temperature of the liquid, it becomes solid. So now let
Sir,
me ask you one question. Yeah. Somebody is asking one question.
sir, when we take a ice cream or a ice,
Yes,
we if we see it carefully, we can see some smoke-like structures are coming out. That are vapors, I know, but it is not getting heated. Then how it is coming out?
very good. Excellent. Excellent question. So when you take ice or ice cream, then you can see some of the smoke. Am I correct? Is it your question, Shivangi?
Yes, sir.
That smoke should be because of
Sir, it
heating.
is not. Sir, it is not getting heated, but how it is coming out?
Yes, very good. That is what. Okay. So when you get heated, then the smoke has to come out. But in the case of ice cream, which is at very low temperature, but still you are able to see some smoke. Yeah. So may I know the reason? Anyone, please? Anyone can help with Shivangi's doubt? Anyone can help you? Ashmi Bishwas, Ariman.
Please repeat her question once.
How many times we have to repeat? How many? I repeated twice, and she has told twice, and you are asking repeat.
Sir, voice was breaking.
This voice will not break, no? Whatever I said, that
Sir,
voice will not break. But the
now I can
questions,
listen. I listen good. That's why I asked you.
yeah, Shivangi, please repeat the question.
Sir, when we uh, take or buy ice cream and we can see some smoke coming out from it, but it is not getting heated. How the smoke is coming out?
Yeah. Now, Sadnik, now you tell me.
Sir, sir, because it is coming contact with the what temperature. That's why
It
little
is coming in contact
yeah,
with the.
sir, little more warm temperature temperature than which it was still staying
Okay,
out of the freeze and coming to the normal room temperature or
okay,
outside temperature.
okay. Yeah. Okay, good. Very good, Sadnik. Any other, please?
Sir, can I tell?
Yes, you can tell. Krishti.
Okay, sir. When we buy a ice cream,
Hmm.
it is cool. But when air cools, water vapor is water vapor in the air condenses into fog, which look like smoke coming from the ice.